Combinations of resistors in series. Here we have three resistors. The first one is having a resistance R1, the second is R2, and the third one is having a resistance R3. So these resistors are said to be connected in series when one end of the conductor is connected to the other end, okay, and so on. So this type of connection of resistor is known as series combinations of resistor. Also, the two free ends of the resistors here, like this end here and this end, these two ends are connected to the potential difference V, and this potential difference V, it will send a current I to this circuit, okay, and it is clearly seen here that this current I, which is sent by the cell, it will be flowing through each resistor. The current through R1 will be I1, the current through R2 also will be, the current through R1 will be I, the current through R2 also will be I, the current through R3 also will be I. Okay, so this is the condition about the series combinations of resistor. Okay, but the difference here is the potential difference across each resistor. The potential difference across resistor number 1, it is V1. The potential difference across resistor number 2, it is V2. And the potential difference of resistor number 3, it is V3. Okay, so it is clear here that this potential difference across each resistor, according to Ohm's law, can be written as V is equals to IR. But the potential difference across R1, it will be the current through R1, it is I, and the resistance, it is R1. So your V1 will be IR1. Similarly, the potential difference across resistance number 2 will be IR2. Across R3 will be IR3. Alright? Now, this total potential difference that you are applying across the combination V, okay, this is the total potential difference across the combination. So this V can be written as a sum of V1 plus V2 plus V3. Alright, or I can see here that this V is equals to, instead of V1 I will write IR1, instead of V2 IR2, instead of V3 IR3. So next what we do is we will take common I. So inside bracket you will have only R1 plus R2 plus R3. Okay, so next step is I will shift this I to the left hand side, then it goes down, and right hand side you'll have R1 plus R2 plus R3. Okay, so now what is this V upon I? This V, it is actually the total potential difference of the cell, and this I, it is actually the current which is sending by the cell. So therefore we can see here V upon I from Ohm's law, because from Ohm's law V upon I is equals to R. So this V upon I will write as RS, which means the total resistance or the equivalent resistance of the combination. So this RS here is equals to R1 plus R2 plus R3. Okay, so this is the equations of the total resistance when connected in series, right? So using this equation 1, we can extend to any number of resistors connected in series. Like if I'm having n resistors connected in series, then the total resistance of n resistors will be R1 plus R2 plus R3 plus dot 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 plus up to Rn. Alright, so this becomes the equations for the total resistance of the combinations of n resistors in series. Right? Okay. Now, a point to be noted here, okay, from this equation 1, we see that the total resistance of 3 resistors connected in series, it is equals to the sum of the individual resistances. That is the first point. The second point is the current which is passing through each resistor is the same. If the current sent by the potential difference is I, then the current through R1 will be I, current through R2 I, current through R3 also will be I. That is the second point. The third point is the potential difference, okay, across each resistor. Like we have seen here, V1 is equals to I R1, V2 is equals to I R2, V3 is equals to I R3, which means the potential difference across each resistor now, right, it depends, or it is directly proportional to the corresponding resistances, because I it is common through each resistor. So this potential difference across each resistors will be directly proportional to their resistances. Okay. Okay. Another point is that the total resistance of the combination, it is always higher than the highest resistance of the given circuit. Like if the resistance R1, let's say it is 1 ohm, resistance R2 it is 2 ohms, and the resistance R3, let's say it is 3 ohms. So when these resistors are connected in series, their equivalent resistance Rs will be R1 plus R2 plus R3, which means Rs here is equals to 1 plus 2 plus 3, or I can say Rs is equals to 6 ohm. Okay, so look carefully about these two equations. Out of these 3 resistors, the highest resistance it is 3 ohms. But when you find the total resistance, right, you found to be 6 ohm. So this 6 ohm it is greater than 3. So hence from here we conclude that the equivalent resistance of the circuit, it is always higher than the largest resistance of the given resistance in the circuit. So this is all about the combinations of resistor in series.